So hey guys, welcome to Winglens. I am Swaroop and let's get started with this video. So in today's video, we are going to take a look at a new flight controller AIO board. So what is an AIO board? Well, an AIO board is basically a board that is a single PCB containing both the ESC and the flight controller module. So generally speaking, the ESC and flight controller module will come in two separate modules, as you can see in this quad over here. See, there are two modules. The top one is the flight controller and the bottom one is the ESC. So the ESC can be taken as the electronic speed controller, which will be basically taking in the power from the battery, then circulating it back to the motors according to the inputs that it gets from the flight controller. But in some cases, when we are looking at some micro builds and nano builds, we don't have much of a space in our frame to accommodate a full size ESC and flight controller stack. In those cases, we need these compact components like the AIO board. So this is a AIO board coming from the company called Sub250, as you can see right over here. So this is a very nice brand, a fairly new brand, I would say. They have this Redfox flight controller. This is the A3 version. So let's get a look into it. Let's see what are the pads we have over here and how we can benefit by using this flight controller over the others that are there in the market. So I got this from DRK stores. I'll put a link in the description. Hopefully it is still in stock in that store, or else I'll put a link to some other maybe portal from where you can get it. So you get this box with a sliding mechanism. It's a very premium looking box, I would say. So I hope this light is not annoying you. I think it looks cool. So let's open the box real quick. So you have this Redfox branding over here. You have some components, as you can see in this box. This is a very nice hard box, a case in which you can store this thing and even other components if you wish to. Let's open it. There is one small card sort of a thing containing these like social media QRs. So we can keep this aside. Okay. What else do we get? We get this foam padding. It's nice. It will protect the thing from rattling around. So this is the flight controller stack. I mean, sorry, the AIO board. So why it is an AIO board? As I said, it has both the modules built into it. So you can see you have all the diodes and the ESC components right in the bottom of this board, and you have the flight controller, the barometer, and the F722 flight controller chip, everything on top of this, right? So this is a very nice looking board, I must admit. I'll show in the computer screen very soon as how you can like program this board, how you can connect your peripherals and your like other components like the motors, the DJI air unit, or the analog camera if you wish to, and the receiver and all the components that is required for the drone build. So as you already got to know that for the build video that I promised in my other videos, I will be primarily using this AIO stack for the build. You can follow my video. You can if you get this flight controller, you will definitely be able to follow my video and build your own quad with the steps I'll be showing. Okay, so you see there are these red dampers over here. These are basically kind of rubber grommets. They are kind of soft only. You will not get this inserted from beginning. I actually unboxed it earlier, so at that time I put those in, so you can just slide them in. It's very easy to do. Okay, you have these pads over here. You can see these 1 2 3 1 2 3. I'll show them in the screen as well after this. So just an overview for now. So these pads will be used for connecting to the motors. We have the battery pad over here. As you can see, these are the positive and negative battery pads. The positive pad is this one, the negative one is this one. So these pads can be used for connecting to the power, the battery power. Okay. Then you have the other stacks over here. See, you can see the T2 and R2 pads, UARTs, the 4V5 pad over here for the 4.5 volts. Then you have, which can be powered from the USB, by the way. Then you have this like other pads over here. There are like I think I can see some LED pads, some ground pads, then some SDA and SCL pads as well. So yeah, you can get some SDA, SCL, I2C devices like a compass or a magnetometer maybe to connect to this flight controller. One thing to notice whenever you buy any flight controller is always get to try to notice where the arrow is pointed. So if you can see clearly, you can see one arrow over here right over my thumb. See in this area. So this arrow is basically pointed that way. So that means this flight controller expects it to be positioned in this manner. Suppose this is the quad facing my computer, so the flight controller should be placed in this manner, right over here. So this is the front orientation that you have to place the flight controller in. So let's get to the computer screen and see how the components are to be connected. So I hope okay, I forgot to mention what all are there in this package. Let me place it here. You can just take off this foam cover over here. So this is the foam cover. We have some wiring harnesses. Okay, this is like a wiring harness to connect it to give it like a USB port. Okay, by the way, I forgot to mention, like most flight controller AIOs or stacks, you don't have a dedicated type C port over here, and that's actually good because we are going to make a micro category of build. That's a Sub250 drone, like a 250-gram drone basically. That's why our drone will be pretty small in size and very compact in its nature of like placement of the components inside it. So that's why we'll not get some like much of a space to accommodate like a type C port, and even if we had type C port, it would be very hard to reach that without opening the drone apart, right? So it's better to have to not have a type C port over here, and thus they will give you this type of an adapter, which is basically nothing but there is this port which will connect to one of these ports over here. This one, see, there is a DM DP port. So wherever you see this DP, DM, 5 volt, BT, these ports, you should understand that this is for the type C connection. Okay, so you can just push this in and that will make the connection. See, I pushed it in, and now I can just simply plug one USB cable here and get it connected to my computer for programming it. So we'll do that later. Let's like keep it aside. What else do we get? We get this nice capacitor. Okay, this is the 470 microfarad capacitor. That will be, I think, enough for this flight controller, whatever power it will be drawing. So that will be pretty fine. A nice and compact capacitor, I would say. So what else do we get? We get this X330 connector. This is a very nice connector. This is having like a 14 gauge wire, maybe, I'm not sure, I have to see. Okay, we also get this harness. This is for, I think, connecting to the air unit, although I will be using the air unit that I got with this DJI unit, like the stock one I'll be using. I'll not be probably using this one. Let's see what we do. Maybe I can even use this one. Actually, I like using that because of the color coding that the DJI one maintains, because we have to disconnect some wires. You will get to know more about that in the air unit video, by the way. You also get some extra grommets, as you can see over here. So maybe I think these black ones are a bit more harder, I think, than the red ones. Let me see. Yeah, I think the black ones are a bit more harder. So it's up to you what type of a dampening you want to provide to it. So let's keep everything aside and jump to the computer screen to understand how this flight controller will be getting connected. So let me just disconnect this. Well, for the specific build that I will be using, I won't be actually using this one, because I have one more PCB design that will be utilizing this. For your case, if you are not going to use that PCB that I will be using for my build, you may keep this and use this as the primary USB driver. So let me unplug this thing and keep everything aside. Okay, so we're in the computer screen. I hope you can see the circuit diagram that is on my screen. So I have made the image full screen so you can see it properly. So as you can see, this is like, I will share this document, by the way, in the video description down below, so you can just grab it from there. So if you are using this flight controller, this circuit diagram is going to help you a lot. I hope there is no mistakes. Anyways, I am going to go through all the connections and all the ports you are seeing over here. So let's get started. So this is the back of the flight controller, that is basically this side. So let's not look at this side first, let's look at the bottom part only. So this is like the top view. Okay, so in the top view, one thing to keep in mind, see, the circuit diagram is made by me, but the board image, I have taken it from the Redfox manual that I received. Okay, the PDF version of the manual that is there within there, like in the basically the website of Sub250. So you can go grab that there as well. But that didn't have the circuit diagram properly. Obviously, that only had like the information about the flight controller board and nothing else. So this AIO board will be having so many paths. So we don't want to get confused and connect to something wrong. So let's follow through. Okay, so starting with the first two pads, that is the battery pads. Okay, one thing to keep in mind is there is one mistake that I just noticed before making this video, that in the image you are seeing on the screen, you would notice that this Redfox writing is not oriented in the correct order, like the real thing. See, in this real thing, Redfox is in this angle, but in the image that you are seeing on my screen, it is like kind of in a different angle. So this is happening because the Sub250 people, they kind of did a mistake, I think, in printing this sticker, or maybe in like designing the circuit diagram, the PCB diagram in the manual. That's why it's a bit wrong ordered. Don't follow this sticker, always follow this arrow. You see over here, this small arrow, teeny tiny arrow over here, which is marking towards the right of the screen. So I have place the image in the circuit diagram also following the same orientation. So that would be the front side of the drone. Just for reference, as I said earlier also, if the drone is suppose pointing towards my laptop screen, the flight controller is supposed to sit like this. Okay, so suppose we are looking at the drone in this manner, where the drone is looking at the right hand side of the screen, the flight controller will be pointing like this, the arrowhead. So let's look at each of the pads over here. So these two you are seeing over here, this is the plus pad and this is the minus pad. You can see in the screen that I have basically connected the red wire to the plus pad and the black wire to the minus pad. So for me, I will be using an external PCB that you are seeing over here for the X330 connection to the outside of the drone, because this flight controller board will be integrated totally inside my frame, which I will be using. So for that reason, I'll need a separate extension board that will be placed inside very carefully and cleverly, so that the X330 connector can be, this connector that you are seeing over here, can be exposed at the proper place and I can get ease of access to it. Okay, also there will be a Type-C port at the baked at the end of this extension board that will give me easy access to the Type-C board as well. So going forward, you can ignore this part for now. You can think of these two pads as the X330 pads that you will be having. So basically what will be the case is, suppose for you, if this is the X330 connector, this this red wire is going to be connected to this plus pad, and the negative wire, that is the black wire or the ground wire, is connected to the negative pad like this. You have to solder them like this, and that will do the job. For me, I won't be using this X330 connector. This is an extra for me, but for you, if you are not using my frame, you would need to solder that. So bear that in mind. Going forward, let's look at the other pads. As you can see, this is very common knowledge that you have these pads, these three pads. These 4 set of 3 pads are basically for the motors to connect. Like the motors have these 3 wires coming out of them, the M1, M2, and M3 and M4 motors. As you can see in this image, they are going to connect to all the 4 tri-padded areas over here. Next, let's go ahead to and have a look at the connection with this GPS module, because GPS module will be something that you'll be wanting to connect next. In today's drones, it is a must to have a GPS module, because Betaflight's this GPS rescue is so reliable right now. The M10 GPSs that you get in the market, they will capture satellites within seconds, and you will be getting a good number of satellites, and you'll be able to return to home without doing any stick movements. The drone will literally take off and come back to you on its own. So that's a very nice fail-safe feature that Betaflight provides in its firmware. So you should have a GPS. That's like a set thing, although you can fly without a GPS as well, but it's always recommended to have a GPS. So let's look at the connection the GPS module will be using. So in GPS modules, I am showing here with a basic GPS module without any magnetometer. If you are using a GPS module that will be having a magnetometer, it will be containing 2 more extra wires, the SDA and SCL wires. As you can see in my big drone over here, you see this has like 1 2 3 1 2 3, the 6 pads over here. So it contains basically the SDA and SCL pads at the end. You can see the A and the L, which indicates the SDA and SCL pads. Those 2 pads are used for connecting this magnetometer component to the flight controller via I2C. Those 2 pads will be required. In our case, in this flight controller, we do have those 2 pads, like the SC and SDA pads are there. You can see over here, I am moving my cursor. I hope you can see those. Okay, on the top right of the over here, see DA and CL. These 2 are basically the SD and SCL pads where you can connect if you are going to have a GPS module with a magnetometer or something. But since I will not be having that, I will not be using such a GPS module, because those modules tends to be pretty big, and my drone is a micro drone, and I want to like check on the weight of the drone, so no need for that. Anyways, the magnetometer reading will be pretty noisy only because like there are so many other components and it's not very ideal to use at all. So other than that, let's look at the other connections that we have at the on the top side of the board, and then we'll look at the bottom side of the board. Okay, so going forward, there is this connection you are seeing. You might be wondering what is this connection about. So basically this is GND V5TX and RX. Why is this used? Because I will be using an external USB port, okay, which is situated right at the back of this PCB you are seeing here, this T-shaped, this Y-shaped, not T, this Y-shaped PCB you see. At the end of it, there is a Type-C port. For that, I need the like some connections to be present, and there is also a boot button. For that, this board is basically, this board is a very useful board, by the way. This is made by Gepard-C. Just for information, this Gepard-C this flight controller extension board is very interesting. You can see in the back side of the board also there is some plugs over here. I'll explain one by one each of them. So you see, this is the Type-C port I was talking about. Okay, this Type-C port will be basically getting its connection through this port, this plug over here, and there is a boot button also here. So those are that will be also getting its connection through it. Okay, other than that, we have this like RX and TX pads over here. You can see GND V5V TX RX. So what are these pads required for? It might seem to you a bit familiar because these pads are basically used for receiver plugin. So you see there are these 4 points over here. These 4 points are nothing but to just plug in directly, like put your receiver pins inside and just solder them so that it just stays over here. The receiver will basically like stay like a box over here, like I hope you can understand. The receiver will be basically directly connecting to these 4 pads, and those 4 pads will be basically nothing but indicating this ground, VTX, I mean sorry, not VTX, ground, 5 volts, TX and RX pads over here. Okay, so this TX pad is going to be connected to the R2. So here I have basically optimized the circuit diagram. You can definitely connect it to R4 or T4 or maybe some other like R6 and T6 depending on the setup you are going to use. For me, I think see, looking at the frame I will be using, looking at the other connections I have, it's best to utilize these ports for the connection. So I'll be using the RX and TX of this R2 and T2 over here, and I'll be using the 5 volt which will be connecting to the 5 volt pad over here, you can see, and the ground will be connecting to any of the ground. You can use this ground or this ground or this ground or whatever ground you want to use it. Okay, so ground is always common, right? So those pads are basically nothing but over here. You can see in the image on the screen and also in this real image. So see here is the T6, the R6, and here you have the R2 and T2. So one thing to remember always is that be it flight controllers of drones or Arduino or Node MCU or whatever it is, any MCU you are using, any like microcontroller you are using, you are going to connect the R2 of this pad to the T2 of the peripheral and the T2 of this pad to the R2 of the peripheral. This vice versa connection should be maintained at all times. Okay, so next going forward, let's look at the we already talked about the GPS connections. The GPS connection will be going over here, you can see, as I also showed you earlier. And then it's pretty simple and so like fine only. Okay, one thing over here you can see is 2 holes over here. So these 2 holes are basically going to be used for connecting the buzzer. So this is like the buzzer plug. It just needs the 5 volt and GND and nothing else. Why? Because we have a buzzer pin on this external PDB that I was talking about. Okay, this external PCB will be containing one buzzer port, which will be basically sending like a digital input to this pad, either 1 or 0. It's either off or on, and that will set the buzzer to on or off positions. Okay, and then let's come to the front, like the back of the board. So let's turn this board over. Let's not turn it this way, let's turn it like this. Okay, so we'll be heading the right direction because we have to maintain the direction of for understanding we have to maintain the direction towards the right as the front. Okay, so here you can see I have like shown the O4 Air Unit Pros. This one basically, if you are not familiar with it, this is the Air Unit Pro, by the way, like the camera and the Air Unit box. So I have basically drawn the back side of the Air Unit box in order to explain the connection with the flight controller. Okay, so you can see there are like many ports over here. It might seem a bit confusing, but it's trust me, it's pretty simple. Okay, so this BZ port that you see over here, okay, the purple color one, this is basically the buzzer port. So this buzzer port will be getting connected to the buzzer port of the flight controller itself. So if you look closely in this first image that I was showing in the front of the flight controller, okay, so here you have something called a BZ. If you can see my real like video footage over here, you will be seeing a port called this B minus B over here. See over here it's written basically. If I look at this way, it will be able to visible more. See this, oh my god, this camera is not focusing. Okay, there is a port. Okay, it is not focusing, it's so small. So this is the BZ port. This is basically the buzzer port where you will be connecting to the which will be connecting to this buzzer connection that you saw just over here, this particular port. So this will be a JST plug. Okay, the JST plug pins I'll have to pull out from the other JST plug port, and I will basically soldering that directly to this BZ pad that I have over here. There is one EM pad which will be using for the transmissional signals, like the data signals that needs to be sent over to this external board for the Type C connectivity. You see there is a Type C port, so we need the Type C port to talk with our flight controller, and for that we need a transmission pad. Other than those pads, what else we need? It's basically the DM and DP pads. So the DM and DP pads, the transmission pad and the 5-volt pads, these pads and the boot pad. Okay, these pads are basically used for connecting to the like Type C port. So basically, since our flight controller is designed for a micro build, so it is not having like that integrated Type C port that usually is there, but in place of that we do have these external paddings over here. You see this is a JST plug which will be basically having these particular connectivity ports, the GND, the DP, the DM, 5 volts BT pads over here. So BT is basically nothing but boot. Why are we using the boot? Because this boot will be getting connected to this BOT. I don't know why they printed BOT, this should be BWT. Anyways, so this boot pad, it will be getting connected to. Why we need the boot pad to be connected to the boot pad of our flight controller? Because we have a boot button on this external board, and that's very interesting. The boot button is going to help us so much because suppose you need to go like flash a new firmware version in this flight controller, and you wanna boot the flight controller, send it to the bootloader mode. In that case, will be not be requiring to enter the open up the entire quad and plug this flight controller and then go into bootloader mode. We can just simply hit that button in the back, and that would do our job. Because you can see there is no external boot button as well in this entire flight controller, so that is gonna help a lot. So I have very thoughtfully chosen this flight controller as the flight controller of choice for this particular micro build. Other than that, what we have over here, let me again revolve this to the correct side. Okay, we have we can leave this ground port if you are wondering why I didn't put any marker over here, because see, the entire board will be having a common ground, so any ground port you can leave it will be ground only, because those will be common. Let's look at this pad. So you see this is having a similar type of a connection coloration with the O4 unit pro over in the top. So two wires that you need to disconnect are basically S bus and GND if you're going to use an external radio controller. Suppose for example, for me, I will be using the TBS Tango 2 as my primary radio controller. That's why I'll be disconnecting those two wires. Those are the S bus and GND wires, the brown and the yellow wire. Why will I disconnect those? Because it's simple that I don't want to use the crossfire protocol only for the connectivity, that I'll be basically connecting to this this 4 ports over here. You see I just showed you a bit ago. Okay, I will be connecting to those. That's why I won't be requiring the S bus and GND connectivity of the O4, because the O4 does have this this feature where you can basically not have any external receiver in the drone and directly use the O4 as your receiver. But for that you need the DJI remote, and I don't have that, so I'll be using the crossfire that I have. And that's pretty much it. It's pretty simple. Okay, I've missed this one. There is a small GST plug over here which will be getting connected to the LED strip that we can connect to our drone and make the drone beautiful, because the LED strip is going to make it look beautiful only, and nothing else. It's going to add weight only. So anyways, I'll see if we don't we are not able to achieve the 250 gram weight target. We may have to discard the LED from the frame. So that's up to the frame. I'm waiting for the frame to reach me. I hope this video helped you. Okay, one thing I forgot to show you guys is how to get it connected to your Betaflight. So let me quickly get this Type C port over here. See, I have this very common Type C port. I can just open it up. Let me first get this connection worthy by just plugging this to this DPDM port I have over here. So this will be the port we'll be using for connecting these peripherals. Keep that in mind. Okay, I think I'm doing it the wrong way. Yeah, this should be the right way. See, we plugged it in. Now we can simply just plug this side to the USB port. It's pretty nice and fitty. let me push this inside the computer. Okay, so I have plugged it in. You can see it's already powered on. There is a light on this as well, and also on this. So actually this is pretty good. You see they also provided two nut holes over here, so you can just screw them to your quad if you have the place to screw them in. Let me quickly go to Betaflight and check it out. Let me see. I hope Betaflight is installed. Okay, we have it. So yeah, see, this is Betaflight. In the screen you can see we have launched Betaflight. If you go to hit connect, it will connect to our flight controller. Let me orient it in the right way. So this is the right way. You see, if I move the this flight controller in the towards the right, if I roll it towards the right, the drone in the preview rolls towards right, and if I roll it towards the left, the drone in the preview rolls towards the left. So it's pretty nice, I would say. It's pretty decent and pretty responsive. It is currently a bit laggy because of the recording, I suppose. Maybe that's why it is lagging a bit, but that's fine. It's just the preview that is lagging a bit, so not an issue. So let's move towards the setup. So see, this is the setup. We can hit calibrate accelerometer by placing it on a flat level ground, and then we can simply hit this calibrate button, and that will calibrate our accelerometer to our likings. Then we kind of, okay, see, after calibrating, it is pretty fine. I think that's the reason it was not calibrated. That's fine. So see, when we move it towards the left, it is moving. Look at the drone in the preview is looking towards the left. If we move it towards the right, the drone in the preview is looking towards the right, and that's pretty much it. One thing to keep in mind if you are going to buy this flight controller, so flight controllers often tend to ship with a kind of a wrong configuration in the orientation tab. So you can take a screenshot of the orientation that I am having over here. You see the board alignment center, the board and sensor alignment section over here in the top right. This will contain the 0 as roll degrees, 0 as pitch degrees, only 45 degrees as yaw degrees. The gyro axle is set to first gyro is set to default and default. So keep an eye on this, take a screenshot. Maybe if you are going to buy this flight controller that I'm using, you can simply use this settings over there, and that will make your flight controller work. Because in many times what happens is, that happened with my other quad also, is that I built the quad, I connected everything, I armed the quad, it even armed properly, and just as I went ahead and increased the throttle to make it do a hover test, the quad just zipped out. It's kind of weird to speak of. It's like as if I turned on turtle mode and the quad jumped here and there and then just flipped. So it was like a miscalculative approach on the gyroscope side, I would say, because in the quad that I built earlier, it used the SpeedyBee F7 flight controller stack, and it had the gyroscope placed right below the quad, so that is basically underside. So what is happening is, when the quad is when the flight controller was sitting this way with the orientation facing front, if I roll towards the right, for the gyroscope it was basically a roll towards the left, and that was somewhat a inverted orientation. So I had to do a lot of trial and errors with the values over in this board and alignment section, and finally I got it to work. Okay, so I hope you liked the video. So this is this board and sensor element is a very important part to look at. Then we have the power and battery section. I will get going through all these steps basically in the main build video, because it's no point of going through all the presets and pre-tuning areas here unless we build the entire quad. So let's wait for the entire quad to be built. We have the mode section here, where we can put on the radio modes, the switches and different items in the radio that we can assign to different aux channels over here. We have the motor tab, from where we can modify which motor to run in which direction. We have the OSD track over here, which I have already basically programmed. Basically I have done nothing, but I've just basically copy pasted the Lua not the Lua script, I think it's like the dump file of my previous quad, the OSD dump of my previous quad, and copy pasted it over here. That I did by just going to CLI and then just writing over here as dump. Okay, it will dump you the entire setting of this flight controller. I did the same for the older quad. I took the OSD portion from here. If you go to this 3, there is a OSD portion over here. I took this entire OSD portion and just copy pasted that OSD portion as a input in this CLI, and just ran that. Okay, I saved that and then rebooted my flight controller, and that did the job. If you are looking for updating the firmware, what you need to do is you need to hit update firmware section over here, and then you can click on auto delete the board. It will auto delete the board for you. But sometimes what happens is this would not work. Okay, this settings that I'm showing over here, this auto delete, if you click on load firmware online and then hit on clicking on and then hit on this load backup button, okay, if you click on it, it will basically load it, okay. But then if you hit on flash firmware, because I have already flashed, I will not flash it again. It might break things if you like, if I reflash it, and I'll also have to like kind of take a backup and then reflash the entire thing again, so I'll not do that. But in your case, if you find that this is failing, this flash firmware button is failing, it is showing as a red over here, maybe it failed to read something or something like that, what you need to do is very simple. It is applicable for any flight controller, in that matter what you are using. You can just simply go to the like Google Chrome, search for, or any browser you are using, search for this tool called Impulse RC. Okay, you just need to write Impulse RC. Okay, Impulse RC driver fixer. So this is basically a driver fixer application which you can download for free without any ads or anything. This will auto detect your flight controller, which you have connected to your like the PC, and it will download whatever firmware and softwares that are like drivers that are needed for flashing the firmware properly. So you can keep the flight controller connected to your PC, download the software. Okay, go to downloads, Windows. You can click on Windows, I think. That will like start the download, I hope. Okay, it's not starting. Let me go to here. Yeah, this will, I think, start. Yeah, see, we can download this application. We can just simply click on this application, that will open it up. Let this application open up, and then after we open this up, it will basically check for updates. It will search for the flight controller that is connected to it, and it will automatically boot that flight controller into the DFU mode, that is the bootloader mode. And then you can just simply manually select the firmware version of your flight controller, which you will be getting to see from the manual of this flight controller. I will also show the manual if you want to. Okay, the main manual of this Redfox A3 flight controller in the video description. So from there you can simply look at the firmware version, select that over in this tab, and then simply click on the flash button. That will surely work. Okay, so that's the fix if you face some issue with this flash firmware button. I hope this video helped. It will take some time. Okay, this installing DFU driver will take some time. See, it's driver fixer fixed. Now you can just simply click on flash firmware, and that will do the job. I will exit the DFU mode and bring it back to the normal mode so that it gets connected normally. Okay, so I hope this video helped you guys. Let me know in the comments if I missed something, or you have any questions. Let's meet again in the next video in the upcoming days. It's going to be a very exciting build. Many more unboxings and reviews and tutorials going to come on my YouTube channel. Very new I am, so please subscribe to my channel. Also share with your friends, your FPV buddies, and your robotics fanboys. So happy learning, happy flying. Goodbye for now.